Today we're working with the Advanced Functions and Modeling Indicators, standard 2.04, which is talking about trigonometric functions. Now this particular standard only focuses on the sine and cosine function. So those are the only ones these examples are going to deal with. And that's all they're going to be tested on, sine and cosine functions. So first thing we must do is we must actually rewrite this function replacing a, b, and c. So we get 5 cosine of 2x plus 3. Now what I always do is write out the amplitude, which in this case is 5. The period in this case is 2 pi over b, so that equals pi. The phase shift, I'm just going to put ps. There is none. The phase shift is usually in here. And then the vertical shift, it goes up 3 units. Okay. Now when we graph this, typically the center of the cosine graph would be on the x-axis. But because this one has a vertical shift, and also we know that on the original parent function for the cosine function, the amplitude starts up at 1. So in this case, with the original amplitude, it would start up at 5 because but it shifts up 3 units. So the original one is going to start up at 8. So its maximum point is going to be up here at 8. But then the minimum point is going to be down at 3. I'm sorry, -2. And I'll explain what I mean by that. And it's going to go back up to 8. And we're going to stop right here at 2 pi because it tells us that it wants us to go between where x is between 0 and 2 pi. Now, looking at this graph, we can draw the center again, and I'll do that in black. And so the center of the graph technically is right here, and it goes right through there. Now notice the cosine function, one phase starts high, goes low, and comes back high. Now let's go ahead and get to the questions. And the questions ask for A, it says discuss the intercepts and the maximum and minimum points. Now in this case, we know the max is actually going to be +8. The min is going to be at -2. Okay. As far as the intercepts, I noticed that within every period you'll have 2 intercepts at this point here and this point here. Okay, so for every period, if we extend that on the x-axis, for every period there will be 2 x-intercepts. Now when we look at part B says as the value of a approaches 0, explain the change in the value of f of x. So simply, as a approaches 0, the f of x approaches 0 as well. So f of x approaches 0. But more specifically, the amplitude is decreased. So this is the important part. The amplitude is decreased, which means not only is the amplitude decreased, but it just makes the graph lower. It's not as high vertically. And so basically the wave, the height on each of these waves here for each period is going to be lower. Okay, so that's the important part for kids to remember. On part C, it asks, as the value of B increases, explain the change to the corresponding graph. And very simple, as B increases, then the period decreases. Okay, so the period decreases as they make that change. Okay, now that's the simpler way to remember this. Once again, so it says in part B, as A approaches 0, basically the amplitude decreases, and as in part C, as B increases, then the period decreases. So that's important. It'll make a difference in the change of the graph. And that's it for example 1 on the AFM indicators.